Welcome to the Explainer. Okay, I am absolutely thrilled to dive into this one with you today because we are going to decode what is arguably the ultimate mathematical puzzle of the night sky. For as long as humanity has been around, we've looked up and just been captivated by the stars. But there's one question that really stands out to me. How on earth did our ancient ancestors see eclipses coming? I mean, it sounds impossible, right? Let's find out together. Section 1, the Ancient Eclipse Mystery. So I want you to just picture this for a second. Imagine stepping out under a pitch-black desert sky in the 9th century. There's zero light pollution, just you and this endless, breathtaking blanket of stars stretching out in every single direction. Now ask yourself, how do you predict an eclipse without a telescope? Think about the sheer impossibility of anticipating these massive, complex celestial events. You've got no satellites orbiting the Earth, you definitely don't have digital observatories mapping the sky, you don't even have a basic magnifying lens to get a closer look. And yet, despite lacking literally all of that technology, 9th century astronomers tracked the sun, the moon, and the planets with astonishing precision using nothing but simple instruments. It's just staggering when you really think about it. They lacked practically every single piece of modern hardware that we rely on to understand space today, but their grasp of the cosmos, it was unbelievably accurate. Moving right along to Section 2, al-Khwarizmi's mathematical revolution. So, to understand how they achieved the impossible, we need to meet the lead detective who kind of cracked this ancient astronomical case. His name was Muhammad ibn Musa Al-Khwarizmi. Let me set the scene for you. It's the early 9th century, and Al-Khwarizmi is working at the legendary House of Wisdom in Baghdad. He was, without a doubt, one of the greatest minds behind this whole scientific revolution, and he ended up compiling one of the Islamic world's earliest and most influential astronomical works. Now, that masterwork was known as the al-Sindhind. And a Zij was far more than just some book you read cover to cover. Honestly, the best way to think about it is like a medieval Excel spreadsheet. It was this massive analog database of carefully calculated tables. It literally allowed scholars to just look up exactly where celestial bodies were going to be at any given time of the year. Section 3, the power of the Z. Let's break down exactly how these mathematical tables functioned, because they were a massive technological breakthrough for humanity. Here's how it worked. You take a celestial body, say the sun, the moon, or one of the visible planets, you match it up with a specific time of year, and boom, the table gives you a highly accurate calculated position. By structuring data in this completely accessible way, they basically eliminated the need to go out and manually observe the sky every single night. But how did he actually build this massive database? Well, first off, al-Khwarizmi didn't just pull this out of thin air. He inherited incredibly robust astronomical knowledge from Indian and earlier scientific traditions. Then, he took that past knowledge, synthesized it, and combined it with some seriously advanced mathematical techniques. Finally, he used these new, refined methods to calculate the precise length of the solar year. Actually, it was more than just the year. He tracked the moon's motion and estimated complex planetary movements too. Crucially, by calculating the exact overlapping paths of the sun and moon, this math could pinpoint the very moments their orbits intersected. And that right there, that gave them the power to predict an eclipse. It was brilliantly accurate and designed for maximum practical use. So the whole takeaway is perfectly captured in this quote from our sources. Instead of watching the heavens every single night, astronomers could use these mathematical tables. I mean, what a game changer. This represents a massive, revolutionary shift in how human beings interacted with space. We went from pure physical observation, just staring up and waiting to see what happens, to predictive, mathematical calculation. Okay, part 4, decoding everyday celestial life. Now, it's really easy for us to sit here and think of astronomy as this lofty, abstract science. But back then, these tables were deeply grounded in daily reality and the pressing societal needs of the 9th century Islamic world. People relied on the calculated position of the sun to determine precise prayer times. They used these tables to identify the beginning of lunar months, which was absolutely critical for religious events like Ramadan. They vastly improved navigation by allowing travelers to understand the relationship between the stars above and their physical position on Earth. And perhaps most mind-blowing of all, astronomers use them to anticipate eclipses. Knowing exactly when the sun or moon will suddenly go dark, all because of an analog database of intersecting math, that is real power. Section 5, a lasting cosmic legacy. Let's take a look at how this all builds into a long-term global impact. Back in the 9th century, al-Khwarizmi compiles the original Zij.
Then, over the following centuries, these foundational methods were expanded and refined by later Muslim astronomers who essentially stood on his shoulders. The idea spread like wildfire. By the medieval era, these tables had reached far beyond the Islamic world. They were translated into Latin, which directly influenced medieval European astronomy and preserved this absolutely vital scientific knowledge for future generations.
And honestly, this just brilliantly illustrates the incredible leap we've made as a species. Think about it. We went from 9th century astrolabes, simple observation devices, and basic math, all the way to modern space agencies launching satellites and running supercomputers that calculate planetary orbits in fractions of a second. Yet those ancient, simple tools produced scientific results that were incredibly useful and remarkably accurate. Because here is the really wild part. The fundamental idea hasn't changed one bit. It remains exactly the same today as it was then. The universe follows patterns that can be understood through mathematics. Whether a massive supercomputer is crunching the numbers right now, or al-Khwarizmi is carefully calculating them by hand for the Zij over 12 centuries ago, the underlying logic is identical. The movements of the heavens are not just random, chaotic mysteries. They can be calculated, they can be predicted, and they can be studied with human reason. Which brings us to a final thought I want to leave you with today. Every single time we predict an eclipse, or calculate a planet's orbit, or explore the deep universe through science, we are actively continuing a journey that pioneers like al-Khwarizmi helped begin roughly 1,200 years ago. So, as we look up to the stars today, equipped with all of our amazing modern technology, what cosmic mysteries will our math decode next? Thank you so much for joining me on this explainer. I really hope this changes exactly how you view the night sky.